So, good afternoon, everyone. My name is Gabriel Wong, and welcome to the webinar on unlocking more features for Fronius Inverters with SwitchDin. We've got some basic housekeeping rules. So, if you join us on Zoom today, this session is going to be recorded and it's going to be available after the event. If you have got any questions, please use the Q&A function and post your question there. All Q&As will be taken at the end of the session. And I'd like to hand you over to Josh McLaren from SwitchDin now. Thank you.
Awesome. So I'm not able to share for some reason, Gabe. Just got to enable my sharing. Cool. Okie dokie. Thank you, Install Legends, for joining. I'm very excited to introduce the session today. So some of you may not be familiar with SwitchDin. So I just wanted to give a sort of a brief overview of what we do and who we are. And then we'll be handing you over to Zuhair and Rod to do more of a deep dive into some of the technical components of this webinar. Alrighty. So a little bit about SwitchDin. As far as the orchestration goes, we're fairly old hat. So we've been around since 2014. We're based in Newcastle, where the majority of our team is based, and we've had a fairly diverse experience in controlling DER assets over many years. So a lot of those learnings have been baked into our software platform, as well as our droplets, which we'll be learning about more today. Another important thing to note is that all of our support is based in Australia as well, so we're Australian technology platform. So we address the 5 families of DER challenges. So connectivity is obviously a crucially important one. Orchestration for things like virtual power plants and a raft of other applications. Optimization to really get the most out of these assets in an aggregated way. The big data that we can pull from these assets, and something which is going to become more and more important over time is cybersecurity. So we address all of these 5 key challenges. So this is a fairly busy looking slide, but don't be alarmed. Essentially sums up what we do. So we connect on the far left, you can see all the different assets that we connect to. So in this instance, we'll be looking predominantly at inverters and battery storage when paired with the Gen 24. We also integrate with smart meters, EVs, and smart loads as well. So those are the core sort of devices we integrate with, who we connect with. So predominantly a lot of our upstream partners, so retailers and DNSPs, C&I customers, government, and also homeowners as well. So there's 3 different ways in which we connect to these assets. So we'll be looking at droplets mainly today, but we can also connect to these devices via an e-droplet or an embedded droplet in the actual device itself, and also via cloud API. So once we've got a integration with the device, it's then visible and controllable by our software platform, which is called Storm Cloud. So that's really where all the magic happens. So we take all these disparate controls and we bring them onto the Storm Cloud platform, where they essentially look like they're uniform assets. And that's where we can do a raft of really great things from this platform. From that, we pull about 600 million points of data every single day, which will be growing to 1 billion very soon. So with all that rich data, we've got our Storm Cloud IQ platform, which gives us some pretty great insight into how these assets are performing, and from there we can make some pretty good strategic decisions. As well, you're going to have the Storm Cloud portal for end users, which is free for all systems under 30 kilowatts. As well, we're going to pump in some really important data into that platform as well, like market prices, weather, and so forth. So the droplet controllers, there's 2 options here, which we'll be looking at. So we've got the residential droplet and the utility droplet. So essentially what these are is an edge computing device which connect to assets. And some of the major advantages of that is that we're brand agnostic. So we're talking in partnership with Fronius here today, but we work with a raft of different brands. So we're Switzerland as it relates to integrations. Some other important aspects is that You can fit multiple different assets onto this droplet. So solar, battery, EV, they can all be plugged into this one system. And it's a very, very straightforward device, but essentially we've got 6 or 7 years worth of software that's been developed by us, all baked into that product. And very importantly, it's a super secure device as well. So the StormCloud platform, as I said, is free to all system owners under 30 kilowatts. And you can bring all those different assets onto a single platform, and yeah, really straightforward at a glance metrics for the homeowner to check. And also as an installer, you can manage all of your systems as well. So that's just a really brief introduction to SwitchDin, but a good way to think of us is we're a bit like a universal adapter. So we're able to provide visibility and control to a raft of different assets, not only behind the meter, but also upstream as well, to provide value to those folks upstream. So I'll hand over now to Zuhair. And one last thing, great news is that if you stay for the entire webinar, you can get SwitchDin accredited. So please stay for the entirety of the webinar, and there'll be some details there which I'll fill you on, and so you can get accredited. So handing over to you, Zuhair.
Thanks, Josh. Let me share my screen. All right. Good day, everyone. My name is Zuhair Ahmed. I'm the lead customer services engineer here at SwitchDin. All right, let's start with a few Droplet basics. So the next generation of the droplets, we are moving towards Droplet 1 and Droplet Plus. It's the same residential and utility droplet, but it will come with a few additional features in line with what we're going to discuss today. Droplet 1 comes with Wi-Fi. Droplet Plus, on the other hand, has 4G capability and also has a rugged exterior, making it more tough and allowing the users to be able to make use of this product in tough environments. Droplet 1 overview, we have a LED indicator on the front side. This is to show what's happening on the droplet, what are different processes doing. 4 USB ports and 1 Ethernet port. The 4 USB ports on this one are DHCP servers. So we're going to make use of these ports to connect inverters, power meters, and different devices using an Ethernet to USB converter. The Ethernet port on Droplet 1 is client only. So this is only to give internet access to the droplet through an Ethernet connection, and it's not used to connect to the other devices. And then we have a power outlet on the other side. The packing list will include the droplet and a power supply. It's a regulated power supply, 5 volts, 2 amps. The main thing to note about this droplet is the operating conditions. We need to make sure that it's operating under below 40 degrees ambient, just because it has a plastic casing. Moving towards the second one, Droplet Plus. This has a rugged case. The software that runs on these droplets is the same. It's the application that's different. So in this case, it has 4G connectivity. So it's a perfect product for off-grid sites, and 4 USB ports to connect devices, and an additional Ethernet port to connect to either internet or connect to other devices. The packing list for Droplet Plus will include antenna for 4G connectivity, and since it's more rugged, the operating ambient temperature is 60 degrees or below. To complete or to configure these droplets, SwitchDin installer app is required. So it's available on both app stores, Apple and Google. So the device, smartphone or tablet running that app needs to also have a valid internet connection throughout the process. And the user needs to make sure that they have the latest version of the app as well. Just a basic note, we always prefer wired connection, internet connection that is, so an Ethernet to the droplet, just because it's more reliable in the sense where we need to not only read measurements off of the devices configured, but also do real-time controls. And in case there is a Wi-Fi extender or a repeater on site, we need to make sure that that extender is not in between the Droplet and the inverter, the Fronius inverter. The reason for that is these extenders, they tend to mask the MAC address of the devices on the other side. So the Droplet won't know where the inverter actually is. So we need to make sure that there are no extenders in between the devices. Powering up the Droplet using the regulated power supply that comes with the Droplet, and also making sure the device using the installer app has a valid internet connection. All right, let's go towards the physical device connections between the inverter and the Droplet. Here we have the Fronius Snap inverter connection, an example of how we can connect different inverters. We need to make sure that Modbus TCP is enabled on Fronius inverters. That's the protocol Droplet uses to talk to the inverters and the power meter. So it's default port 502. I'll go into the details of how a user can enable that. So an example here, we have 3 Fronius inverters all connected to the same network as the Droplet. It could be either wired or wireless. The Droplet also supports daisy chaining in the case of Snap inverters. So if these inverters are in a master-slave configuration, the Droplet will be able to configure them in this way. The process is the same. If they're in a master-slave configuration or if they're independent devices, the Droplet configuration would remain the same. If the Fronius configuration is all set, the Droplet will know that it needs to access slave devices via the master inverter. To enable Modbus TCP, a user can do that from the inverter's web server. So while accessing that server, they wouldn't require the inverter's password. Once that's up in Modbus settings, the user needs to make sure TCP is selected, port 502 is entered, and then clicking on this tick button will save the settings. So after enabling Modbus TCP, the user needs to put in a fail-safe. So this is where, well, I should explain it this way. If in an event where the Droplet loses comms with the inverter, we need to make sure the inverter knows what to write to make sure that the inverter is in a state where the Droplet, if it comes back online, it'll be able to rewrite the controls. So the user needs to make sure in the DNO editor that they select limit the entire system. This is where they can add a set point so that in case there's a comm loss event, the inverter will follow that set point. In this example here, we have 1500 watts, which is 1.5 kilowatts added. And clicking on the tick button will save the settings. In the same DNO editor, once a user scrolls down, they will see controlling priorities. I'll just stop here for a second. This is what we the Droplet would need. That is, the control via Modbus is priority 1. So if that is not made as priority, the Droplet won't be able to write controls. It will still see the device, it will read measurements, but it won't be able to write the controls. And that is in line with the new features that we're going to discuss shortly. So controlling via Modbus priority 1 and dynamic power reduction, which we've just discussed now, would be priority 2. And IO control could be the priority 3 here. All right. Moving on towards Gen 24, it's the same protocol, Modbus TCP, default port 502. An example of different Gen 24s connected with the same Droplet. Could be wired, could be wireless. We just need to make sure that they're on the same network and same subnet. So one more thing I should add here is that the master slave configuration is not supported yet for these Gen 24 inverters. So yeah, we need to make sure that all of them are connected on the same network. Enabling Modbus TCP, same as the Snap inverters, need to access the inverter's web server. Within the web server, the user needs to go in communications and enter the Modbus settings here. Need to make sure slave as Modbus TCP is enabled, 502 is entered, and inverter control via Modbus is also enabled. Once that's done, the user needs to put in a fail-safe within the inverter. It's the same as the snap inverters. We need to put in a set point to make sure that inverter follows that set point in case of an event where we lose comms with the droplet. So in case of Gen 24 inverters, it's called export limitation. It's available in safety and grid regulations menu. Within that, once a user selects this, they need to make sure they select limit entire system from the drop-down menu in mode section here. After entering the DC value, they need to make sure soft limit is enabled, and they can put in a set point. Once that's done, we need to make sure that the droplet has priority to control the Gen 24. That can be done from the IO power management within safety and regulations menu. In there, Modbus control, the user needs to make sure that it's set as priority 1. All right. Once that's done, we need to make sure that the physical connections on site are all good. So there are two options that we recommend. Option 1 is to have a wired connection between the droplet and the inverter using Ethernet to USB converter, which will go into one of the 4 USB ports on the droplet. As I said before, the Ethernet port on droplet 1 is just for droplet's internet access. It's not used to connect the inverter. So inverter to Ethernet to USB converter to the droplet, and the droplet can either be connected to the network via Wi-Fi or a wired connection. Wired is always preferred. Option 2 is to connect the inverter to the network, wired connection that is, and to connect the droplet to the same network, wired or wireless. And if we need to make sure that they're on the same subnet as well, and there are no Wi-Fi extenders or repeaters in between. So just adding to that point, if an extender is on site, we need to make sure that the droplet is on, the extender is on the other side of the droplet. It's not in between the droplet and the inverter. All right, once the devices are physically connected, the user needs to commission the droplet using the installer app. Just a basic indication of the 5 LEDs. These LEDs would be flashing. So we got power, Wi-Fi, iNet, SwitchDin, and devices. By default, droplet 1, if it's powered on, it goes into a hotspot mode, which allows the user to connect to the droplet either through the installer app, which will be a process in the configuration steps, or they'll be able to see droplet come up in their phones or tablets Wi-Fi settings. So an indication of that is the iNet LED will be blue. So yeah, we need to make sure that they're using the latest version of the app. So yeah. On the app, if it's first installation, the app will ask the user to create an account, a SwitchDin account. Once that's done, this is the first screen that will come up. A user can scan the QR code or manually enter the code that's the Droplet's ID. Once that's done, the app will ask the user to create or choose from an existing portfolio. I'll quickly explain what a portfolio is. A portfolio, a user can imagine a portfolio as a folder, whereas each site will be a unit within that portfolio. So there could be multiple units within a single portfolio, and a user can have multiple portfolios as well. We just need to make sure that in case the user wants or if they're doing a site which requires an agent, they're using a same portfolio. Once that's done, the app will ask the user to either create a unit or select from an existing unit. They can create a new unit by clicking on this plus icon here, entering the name and address, and then add Droplet to add the Droplet to the unit, which will exist inside that portfolio. All right, the next step is to specify how the Droplet is connected with the internet. If it's Ethernet connection, which is preferred, the user will need to select connect via Ethernet. The second option here, it will skip all the Wi-Fi configuration steps. But if it's a Wi-Fi connection, the first step, the first option here is what the user will need to select. The Droplet will ask, sorry, the app will ask the user to disable mobile data. Once that's done, they will be able to connect with the Droplet. Once the app is connected with the Droplet using the Droplet's hotspot, the user will be able to see all the Wi-Fi networks the Droplet can see. So selecting the right Wi-Fi network, putting in the right password, will then connect the Droplet to the internet via Wi-Fi. Manage devices. Once a Droplet is connected, this message appears. It means the Droplet is online. Manage devices is where a user can enter or configure the inverters and power meters with the Droplet. Clicking on Manage Devices, this screen will come up within the app, and plus sign here will allow the user to add a new device. Discovery is going to be the option a user will need to select in any case. Manual is for SwitchDin use only. So clicking on Discovery, Manage Devices, provided the inverter Modbus is enabled, port 502 is open, and all the physical connections are good, the inverter and power meter will automatically show up in this page. For meter configuration, this is a crucial step. We need to make sure that the Droplet knows where the meter is connected. So we have defined meter roles for that. So if it's on the grid side, grid role, meter role, load meter role, PV meter role. This is quite important because the new features that we have implemented, they look for meter role from the devices that are configured with the app. So meter role selected and configuring the meter by clicking on the yes icon here. Yep, so to configure the inverter, if it's in discovered state, this blue spanner icon will come up and the user will be able to configure the inverter. They'll be able to see the device model, the serial number, just so they know that this is the actual device they want to configure. Once the devices are configured, the app will take the user to this page. This is the unit where the user will be able to see site aggregates coming through. This is just a summed up picture of what's happening on site, accumulated PV, battery, load, and grid. Stream is where the user will be able to see device-wise measurements and each metric keys coming from individual inverters and power meter. And they get updated every 10 seconds. To add an end customer to their unit, so within the app, the user will need to go in settings, users, and then invite the end user via their email. This will send an email to the end customer or any user following a link. Once they follow that link, they'll be able to create a SwitchDin account and they'll see the unit and portfolio in StormCloud. All right, just a few troubleshooting steps. The LED indicators for Droplet 1, they are a good place to start troubleshooting the device. In case the LEDs, they don't come up, power cycling the Droplet could help. There are 2 tiny LEDs inside the Droplet 1 case. If they're not running, then that could also mean the Droplet processes are not running. So yeah, and also if Wi-Fi or hotspot is enabled on the Droplet, the LED indicators also tell the user what's happening. If the Droplet is not connecting to the network, it's a pure IT issue. If the Droplets hotspot is working, that is, if a user is able to connect with the Droplet from the installer app, well, a good check would be to make sure the network on site is all good. If it's a wide connection, then the user can also power cycle the Droplet and also make sure if their phone or any smart device on site is connecting with that network. In case Wi-Fi network changes, so if it's a new network altogether, that is a new network SSID with a new password, the Droplet will automatically go in hotspot mode. So the user will be able to configure the new network using the installer app as specified before. But if the password is changed and Wi-Fi SSID is the same, that's where we need to delete the network from the Droplet. We haven't added that yet on the front end. So in that case, a user can contact SwitchDin and we'll be able to delete the Wi-Fi network. It will make the Droplet go back to hotspot mode and they'll be able to configure the new network. We have a dedicated support desk, as Josh highlighted. It's all Australia based. So you can send us an email at support@switchdin.com or call us on our support desk number. All right, once the inverters are configured, this is a feature that the Droplet enables for end users to remotely access the web server. So it's both port 80 HTTP or port 443 HTTPS. Once the devices are configured on site, the user can access the web server by creating a tunnel from the web application, which is pwa.switchdin.com. So it's to log into this application, it'll be the same SwitchDin account as of the installer app, and the user will be able to see their unit and portfolio come up. Firefox browser is preferred for this just because the Google Chrome, it tends to get stuck with different certificates and all that stuff. So this is the PWA landing page. It's a unit configured from the installer app. So within this page, if a user goes to Equipment tab down at the bottom, they'll see Tunnels tab up on the top. This also depends on what level of access a user has. So if they have higher level of access, they'll be able to see this tab. If they have basic monitoring access level, they won't be able to create tunnels and also see the device in the Equipment tab, that is. Clicking on tunnels and plus icon here will allow the user to create a new tunnel. They'll be able to select the configured device, Fronius PV inverter in this case. This will get filled automatically. It will create a tunnel for 10 minutes via port 80, which is HTTP. Create a new tunnel, will then put in this entry. Following this link here, will remotely access the inverter's web server. So this is same as connecting to the inverter locally and then putting in a password to access the web server. They can also close or stop the tunnel by clicking on the stop button. Yes, it will close the tunnel. All right, moving towards the new features / controllers. I'll quickly explain what these terms mean in Droplet world, Stormcloud world. As I was saying, devices, while going through the configuration process, we refer inverters and power meters as devices, whereas controllers, they are the devices that control the inverters that are configured. So all the new features that are released or in the future that will get released will come under controller section, which then gets configured with a device and performs real-time controls via Modbus. All right, so first, we're going to discuss peak shaving controller, also known as import limiting for the battery control. This controller or new feature, it works off of battery's state of charge. So it writes to the device after gathering what the actual state of charge or battery charge is at a given point in time. There are 5 modes of operation within this controller. So the first one is self-consumption mode, which is the controller will limit grid import and export. It will have a target of 0 and will do normal self-consumption. The next mode is limit financial. So if the controller goes into that mode, as per the battery SoC, it will limit the grid import by discharging the battery if it exceeds, or if the battery is, or if the site is still exporting, it will charge the battery. The next mode is limit protection. It will limit maximum grid phase. It's just an extension of the previous mode. It will limit the maximum grid phase current by discharging the battery if it exceeds, or if the site is exporting, it will charge the battery. Charge only mode is where the controller will only charge the battery. If it's exporting, there will be no discharge. And force charge is to force charge the battery if it falls below the limit. So this controller, it doesn't take into account the on-site PV, just works off of the battery. So the site can add multiple or more PV if, and this controller will just work off of the battery measurements. The SoC selection for these modes will be the lower limit. I'll explain what this means. And one more thing, it also supports hysteresis, which is it will only go into the next mode until that hysteresis limit is reached, which is 2% on either side. So configuring a controller is a simple process. Once the device's inverters are configured and the parameter is configured as well with the Droplet, within the equipment tab, there is a controller tab available. Also depends on what level of access a user has. Going into the controller tab will bring this up, and a user can enter a new controller from this plus button here. So in this case, it's a peak shaving controller. So from this drop-down menu, a user needs to make sure they select the right controller type. They can put in any name or description, doesn't really affect the functionality on the back end. And they can enter different parameters for this peak shaving controller. In this example here, we have 70% SoC, which is the lower limit for mode 1, and 20% is the next SoC limit for financial limit mode. So in this case, the controller will change modes once the battery hits 70%. And if we add in hysteresis, so in this case, it will be 68%, which is 2%. And the grid import limit in kilowatts and the rest of the modes. A user can also disable a mode if they want to, if they put in, so for example, in this case, if the grid protection SoC threshold is put as 20, which is the same as financial limit, the controller will skip this mode and go directly into the charge mode. After putting in parameters, the controller will ask the user to select the Droplet from the drop-down menu and put in the devices where the controller will do all these controls. They need to make sure they've added the power meter, which will have the grid meter role specified. This is for self-consumption mode within the peak shaving controller. All right, so the next one we have is multi-site export limit controller. We can also call it multi-inverter export limiting controller. So this controller will maintain grid export below a threshold by limiting the PV output. So another feature that comes with this controller is it has an artificial grid offset parameter available. So say if there's a site with higher loads, if a user wants to test PV curtailment, they can put in an artificial test grid offset and then see the device is curtailing. This controller can coexist with the peak shaving controller. So in that scenario, we'll have a limit on both sides. So export limit as well as the import limit. So configuration steps, it's the same as peak shaving controller. Within the controller section, clicking on plus icon and selecting multi-PV site export limit controller from the drop-down menu, name and description, and entering the parameters. By default, the test grid artificial offset is 0, and this is the export limit, grid export limit value in kilowatts that a user will need to add. Adding in the devices will then allow the user to add the controller. Again, they will need to make sure that there is a power meter configured. All right, so the last one is multi-battery self-consumption. So if we have multiple Gen 24s on a site, this controller will maintain grid target as 0. So there will be no import or export. So yeah, this controller will distribute the set point across all the batteries. It won't attempt to balance the state of charge of a particular battery, and it can perform self-consumption on either a single battery or a group of batteries added to the controller. So it also needs to have a reference, which would be the grid meter. In this case, same as before. Once the devices are configured, the user needs to make sure grid meter is added. One thing I should add here is this controller won't work in conjunction with the peak shaving controller, and the reason for that is there is already a multi self-consumption mode added in that controller. So it could either so a user can either make use of that as a mode or configure multi self-consumption controller itself. In the equipment tab in controllers, they can add this controller by clicking on the plus icon and multi-battery self-consumption from the drop-down menu. It won't ask for the parameters because it will take the grid measurements automatically from the grid meter, and adding the devices, adding the controller will then add this controller to the device, and we'll see self-consumption on the device level. All right, that's pretty much it from my side. I will now hand over to Rod. Rod is Solutions Manager at Fronius. Will give us more insight on the product itself. So, yep. Over to you, Rod. I think you're on mute, Rod.
It might help if I'm new. Can you guys see the screen on my side too?
Yep.
Yeah, great. All right. Yeah, hi everyone. So thanks for that, Ahmed. That's great stuff you've been going through there. So I'm Rod Dewar, Solutions Manager at Fronius. So probably quite a few of you know me already. So I'm just going to cover off some of the things on the Fronius side, which is a bit different to potentially a normal install that you might know. I'm just going to cover off a few basics before that too. So yeah, I mean, there might be some people on the line here that don't know much about Fronius, etc. So we're a 75-year-old company. We've got 3 business units that we run. So the solar is the one we run in Australia. We've got welding, and we've also got battery charging. We're pretty much a global player. So we're in like 34 various countries where we have a subsidiary set up, and many other countries where we have sales and service. And we've got multiple subsidiaries and offices around in Europe. So some of the things you've seen in the presentation today from Ahmed about the Gen 24. So that's a newer inverter that we've just brought out over the last 6 to 8 months, and that'll be increasing out in the market as we go forward. So one of the things, I guess, about that inverter, which is a bit different, where we've really strived to make some differences here, is it's probably one of the most sustainable inverters in terms of manufacturing and service in the world. So, you know, the factory and the manufacturing that we use runs on around 81% renewable energy. The actual things, like say the componentry and things that go into the inverter, 90% recyclable. Also raw materials, a lot of raw materials, some of those are also recycled materials that we use, for the aluminium, etc. And also the transportation, we have a big emphasis on that, on maintaining that as to be as low as possible. If anyone's interested in looking at the whole range of things that we do, then there's a link here at the bottom of the slide, and that's available on our website as the full sustainability report, which you can read, which is quite interesting to get a real insight as to what we do there. So the Gen 24s, just some basics on that really. So for the users don't know yet, we've got the two versions of 3-phase and single phase. So the 3-phase one is the SIMO. So SIMO Gen 24 Plus. So that comes in 2 chassis types. So power class 3 to 5, and then also in power class 6 up to 10. Both are dual MPPT with a DC input on them. Then we have the Primo, which is single phase. And at the moment, we have the size from the 3 to the 6 kilowatt. And that's also dual MPPT with battery input. So in terms of the batteries with it, at the moment, BYD premium battery is the compatible battery at the moment. We are working on a few more going forward. So at the moment, they're the premium HVS and the HVM. So the HVS is short for high voltage small in terms of the range it provides. And then the premium is the HVM, is for high voltage medium. So they come in terms of a single stack. Each one goes up to, so the S's go up to about 10.2, and then the M's go up to 22.08 roughly. You can do multiple combinations of that. So we have a bit of a cheat sheet. So if anyone's interested, on our website, we have a cheat sheet which shows you all the different capabilities and compatibilities of multiple stacks. So all of them can do up to 3 stacks. Depending on which size, etc., you're looking at, you need to make sure you check with that table. But it gives you a really wide range of uses there. So in the HVS, you're looking at around about 5.5 kilowatt hours, right up to about 30. And then in the HVMs, you can go right up to around 58 kilowatt hours. Also with the BYD, we have had a lot of testing done on that from independent institutes. So one of those is in Berlin. And they've tested a whole bunch of hybrid systems with batteries. And one of the things that we really look at is the efficiency, so the overall efficiency around round trip of the system. So we've come out on top on that with the SIMO Gen 24 Plus, and we've also got some testing done on the Primo, which is also right at the top. Okay, so getting to what are the possibilities? So look. Ahmed's covered off quite a lot of things there, so I just wanted to kind of recap on some of that, so it gives you a bit of an overview. We'll start off with that. So the feature sets and things that that you can provide, or they can provide with the Fronius now. So when we look at export limiting, so any systems which have multiple Gen 24s with them, so if you've got multiple ones on the site and you need to export limit the whole site, that's where the Droplet is good to come in. Also, we have some mixed systems. So let's say some systems have a snap inverter on site and you're looking adding a Gen 24 to that. So the Droplet is used for that in order to do export limiting for the whole site with that. And also with systems which are distributed or dispersed on various buildings, that can also be used through that as well. So in the case of the snap inverters where you can't actually solar loop or connect daisy chain the inverters together, this is where the Droplet can come in and work on buildings like that. So it gives you an overall site export limiting function with that. Then you got the battery self-consumption with multi-inverter. So yeah, if you've got a single inverter, single Gen 24 with a battery, it's not necessary to have the Droplet. I mean, there's other features and things you get with it. It's not essential. However, when you do have multiple inverters with batteries on each one, then you would need it. So if you have just a snap inverter and a Gen 24, so you only got one Gen 24 and there's no export limiting, then again, you wouldn't also need it in that case. And then your peak shaving. So obviously that's pretty often probably more for commercial systems, which will then entail multiple Gen 24 inverters with a battery on each one. And that's where that would come in here as well. So some of the inverter settings, which are just slightly different, that I'll go through, which are in terms of your normal setup. So some of the requirements, so this is for systems which are mixed inverters, so mix of a snap inverter and a Gen 24, or ones which have just multiple Gen 24s. So it's only needed with one smart meter is needed in this. So if you look at example number 1, this is a site where you have maybe potentially export limiting on there, and you have a mixed inverter, so your Gen 24 and snap inverter. you only need to have the meter connected to the Gen 24. So it goes onto the Gen 24 because if you do at some stage need a battery on it, then the battery inverter always needs to have the meter connected directly to it. Then you got the other example down the bottom. Example number 2 again is 2 Gen 24s. In that case, if they've got a battery or no battery, it doesn't matter. You only need one smart meter connected to one of the inverters. And Ahmed covered that before. So activating Modbus TCP on all inverters is required. Controlling priority must be set to Modbus 1 because otherwise it won't be able to control the inverter. And also the fail-safe would need to be enabled for the export limiting with that as well. So just as a note there, there's no daisy chaining or master slave arrangements with Gen 24s because there's no communication between the inverters. So just note that down if you don't know. Yeah, so multi-Gen 24 systems with batteries. So you can see here an example. This is one with which got 3 inverters on there. Only one smart meter is required for this because SwitchDin use the data from the meter. They get it from the inverter, but they transfer it from the meter through to the droplet. So you only need one on these sites as well. On the other inverters, however, in order to add the battery to it, you will need to activate the battery or like the meter on there, sorry, even though it's not connected. And I'll show you what that looks in some slides. You activate the battery, of course, activate the Modbus TCP on all inverters, and again, enable the Modbus controlling priority 1. Enable fail-safe, really, you probably only need to enable that if it's an export limited system as well. So let's have a look at the web UI on here. So this is a web interface, user interface. So activating the meter, that's done under device configuration and components. And so you need to do that on the inverters which don't have the meter connected to it. You still need to configure the meter because otherwise it won't let you add a battery to it without having the meter. So, I mean, the inverter will complain and just say, you know, there's a warning message, say there's no meter connected, but you just ignore that. That's okay. It still will function as needed. Then we look at a bit of Solar.web, so some of the differences in there. So with that, all the devices are combined in this, so you can see the whole site on one Solar.web system. Where previously, as soon as you have multiple smart meters in the primary position, so like feeding point or consumption path, as long as it's a primary meter, you can't have them in the same Solar.web system. So with this, because we don't have the meters actually running on the secondary devices, you can have it all combined into the one Solar.web system and see all the data all combined. So you just need, by doing that, yeah, it's just the usual thing, add your data sources under the settings and components. And if it's a snap inverter, you need the data log ID. And if it's a Gen 24, you need the serial number and the V code from the side of the inverter. And there's some different things. So on Solar.web, in terms of the visualization, just with the bubble graph. So if you've got, let's say in the case where you've got multiple Gen 24s, so you've got 2 Gen 24s, both have battery connected. The combined DC value in the bubble graph there, that will combine both of the PV or the DC values of both inverters. With that, the battery SOC, so the way that works is if you've got 2 batteries and let's say one of the batteries is sitting at 80% SOC and the other one happens to be sitting at 20%, just depending on what's been happening on the site, then it adds those together and divides it by the number of batteries. So the displayed SOC in that case will be 50%. So it gives you a percentage of the overall storage for the whole system. The site load at the moment is not calculated correctly. However, that is something which we're implementing going forward. And then in terms of the energy balance, so even though just that one thing is on the bubble graph is not 100% correct there, the values in the energy balance are however correct. So it adds all the consumption data together, the site production and the battery usage. So the battery SOC also displayed there as a combined value. Also the amount of power going in and out of the battery as well. So they're just basically some of the differences if you're used to Solar.web with other systems, just some other differences to be aware of. Okay, thanks. All right, well, that's it for me. And I'll pass it back to Ahmed.
Thank you. All right. So I'll just quickly show a test unit, which is configured with multiple Gen 24 inverters. So PWA, this is the Now tab where we're seeing site aggregates coming through from each device. So in equipment, we have two Gen 24 inverters configured. One of them is Primo, the other one is Simo. And if we click on each device, we'll see the device attributes and serial number and all the device information. So there are currently two controllers configured on this one. If I click on this menu here, I'll see how many controllers are running. So we have peak shaving controller with these parameters, and we also have an export limiting controller. So in this example, we are limiting both sides. So I'll just quickly show what this controller has done. So the first mode, self-consumption, the limit for that is 70%. So if the SOC falls below 70, it will go into the next mode, which is limit financial, and grid import limit here is 1 kilowatts. So if I go to history, so analytics in overview tab is where all the historical data is. So we have 1 minute data granularity, and a user can select a day, week, month, or even a year view, and they can go back in history to view a certain day. So if we, let's say, open up this this graph, so we have on the right, we have a legend, PV, load, grid, and battery power. These data points are plotted. So this is a drop-down menu where a user can select different metrics to get plotted in this graph. If I select battery SOC as well, so it just makes a weird scaling thing because it's a very high value. So around here, if it's visible, the battery SOC went down to 70%. And after that, the Droplet, the controller running on the Droplet went into limit financial mode. If I zoom in this area here, so just zoom in here. So this is where self-consumption was happening. The battery SOC was greater than 70. As soon as PV went down and battery SOC went below 70, the grid import kicked in. You can see it's limited at 1 kilowatts in blue. So in addition to the battery discharge at negative 2 point something kilowatts, the grid import at 1 kilowatts is feeding to the load on site. And in the morning, when the battery SOC was greater than 70, it was doing self-consumption. So in blue, you can see it's following 0 the entire time. And in stream tab here, the user will be able to see the metrics coming through each of these configured devices. And yep, that's it from my side. I'll hand it over back to Josh. So yep, over to you, Josh.
Awesome, thank you. All right, so not too much longer to go now, guys. So thanks everyone for sticking with us. So just to wrap up, we have 3 authorized distributors for SwitchDin products. So supply partners, Solar Juice and Trade Zone, which should all be familiar to most of you. And yeah, just another reminder that StormCloud is free to all end users. So a great addition that's device and brand agnostic for all your installers out there. Now training and support. So I'll give you guys the URL shortly to finalize your accreditation. But for any of your colleagues that are keen to get accreditation too, it's really straightforward. Just go to switchdin.com/academy and they can do an online course there of commissioning 101. And yeah,
Josh, just I don't think you got your slide up. I think if you're yeah, there's no.
Oh, sorry.
Yeah,
right. Okay. Oh, so let's go back. Sorry. Thanks for that, Rod. Okay, so yeah, so the 3 authorized distributors there. and so they'll be familiar to you all, hopefully. And yeah, switchdin.com/academy. So everyone that stays on this call will be accredited. And yeah, support is normal business hours. If you do require support outside of hours, please let us know, and give us plenty of advance warning, and we can see if we can make someone available outside of hours if required. And yeah, support at SwitchDin is just a great place to lodge any tickets or issues. So please feel free to utilize that. And yeah, to complete your accreditation, so switchdin.com/Fronius21, and you will have had to stay for the whole webinar. So and we've got that on record. So if you could chuck that into the chat, Gabe, that'd be great. And everyone just copy and paste that link or type it into your URL and put your details in and follow the prompts, and you'll receive your accreditation pack. But that is a wrap, and thank you very much everyone for staying. Really great attendance, and understand you're all very busy, so really appreciate you taking the time out of your day to do this webinar. So now we're going to get into some Q&A. So I think I'll let Gabe take the lead on moderating the Q&A, and we'll do our best as a group to answer all of your questions that haven't been answered already.
Wonderful. Thank you very much. Our first question is from Sakit. What is the cost difference between Droplet 1 and Droplet Plus?
Yep, that's a good question. So ultimately, we can't tell you pricing. That's up to authorized distributors, but I can tell you that it's roughly triple the price, essentially, for a utility droplet versus a Resi droplet or Droplet 1 or Droplet Plus. So please reach out to authorized distributors, and they'll be able to give you official pricing.
Wonderful. Next question is from Andrew Thompson. For the SA scheme, if I recall, you couldn't just connect the Droplet to site Wi-Fi and connect the Fronius to site Wi-Fi for them to interact. What differentiates when you can use wireless versus needing to do it hardwired?
It's probably a Zuhair question, I'd say.
Sorry, what was that? Which question was that?
So how do we establish whether we can get away with using Wi-Fi or whether something needs to be hardwired?
Well, I mean, we always preferred a wired connection, and it always comes down to what's available on site. If it's not possible to connect the devices next to each other, so say for a site where a home router or the modem is not near the inverter setup, then that way in that case we need to have a Wi-Fi or wireless connection. But to be able to determine what's the better option, I would say it depends on each site, and we would always prefer wired if that's possible.
And also, I think it's important to add there's probably financial implications to the end user, because if the system's not visible through flexible exports for 2030.5, then it'll revert to the 1.5 kilowatt limit. So they'll potentially miss out on some pretty major benefits there. So yeah, just to add to that, so yeah, every system you can wire, please do. If it's not an option, please reach out to us and we'll do our best to support you.
A question from Daniel. If the Droplet and inverters are all connected to one router on site, can this connection be used for WAN connection as well as Modbus connection?
Yep. So Modbus connection uses a different port, which is port 502. And you're absolutely right. If all the devices are connected to the same network, the Modbus traffic will be independent of the other communication traffic. So we need to make sure they're on the same network, and Droplet Modbus connection won't get affected with other devices.
Questions from Sakib. Are there any specific Wi-Fi extenders which we can use and they don't cause communication interruption between the SwitchDin node and the inverter?
So the issue with Wi-Fi extenders is that they once a device is on the other side of an extender, it will have the MAC address of that extender, or a spoofed MAC address. So that's a challenge, because if we want to incorporate these changes or the fact that an extender is spoofing the MAC address, we need to add a whole database of MAC addresses. So we haven't done that at the moment. So it's the solution that we have is we just avoid, or we don't want Wi-Fi extenders on site. If there is an extender, we need to make sure that the droplet itself, the internet access to the droplet, is connected to the extender, and it's not in between the droplet and the inverter. So yeah, we can have an extender, but on the other side, not in between the devices.
Next question from Stacy. What is the role of the solar company or electrical retailer in this? Do we have to configure while doing grid application or solar installation, or we have to guide our installers to do further SwitchDin configuration and troubleshooting?
Well, I can answer the second part. The droplet configuration, a user can do it remotely, provided the devices on site are all connected in the right way, and if there is no Wi-Fi configuration required on the droplet. But having said that, training the installers is always the best way, because they are on site, and if there's something missing as far as droplet to device connections is concerned, they'll be able to sort it out. There are no electricals involved in droplet installations. It's just connecting different comms cables with the device and running the installer app. The first part of your question, I'll let Josh or...
Yeah, I think the best way to answer that is, as it relates to interconnection, the droplet's not a requirement unless it's for flexible exports. And if flexible exports are a requirement in your area, let's say you're in South Australia or AusNet, then you'll know about it basically, but it's not a requirement for interconnection outside anywhere with flexible exports at this point in time. But do bear in mind, it's better to have your installers trained, because I think you're going to see more and more flexible exports being rolled out, and droplets being a requirement for that. But just to add to what Zuhair said, that's not an electrical device, it's more of a communications device. And if that's a requirement at the point of interconnection, you should be highly aware of it leading up to the installation.
Yeah, the only time where that might be a bit different is if you, let's say you got 2 Gen 24s or something on site, and the export limit is lower than the, an uncontrollable one, so to say, then that's something that you may need to have as an export control device, which is not essentially flexible exports.
Cheers, Rob. Thank you.
Wonderful. Next question is from Tim. Can the droplet integrate with wholesale energy companies like Amber Electric APIs to change or discharge based on electricity prices?
Very good question. And all I can really say at this point in time is watch the space. So if you're becoming accredited, which you will be, if you follow the prompts from, I'll put that back up, then you'll know as soon as that becomes that technology becomes available. But yeah, can't really say too much more than that at this stage. But certainly, you can probably figure that we've got the capability to do that. It's just a case of releasing that. So yeah, keep your eyes peeled.
Next question is from Matt. Is there a roadmap for AS4755.2, IEC 61860, and or IEEE 2030.5?
Okay, so for the first part, that's an electrical standard or requirement. So that's not really, like Zuhair said, something that we're involved in. For the latter, for 2030.5, 100%. So we're right at the leading edge alongside Fronius with some pretty significant trials happening in the space. So yeah, 100%. That's certainly an area that we're of strong focus for us, and will be another reason why being accredited is going to be highly valuable as an installer.
Next question is Anirudh. Is there a fleet view if we have multiple systems that we want to view as installers? Correct.
So as an installer, you've got the fleet view, and you've got the ability to monitor all the systems that you install as an installer, which is a real benefit. You know, you can have different products and brands and devices all on the single view, and you can also set alerts and whatnot to be really proactive with your customer support with your end users, as opposed to being reactive. So yeah, that's certainly a major benefit of utilizing the SwitchDin platform.
Yeah, just to add one more bit, that's where portfolio setup comes into play. You can set up portfolios as per your customers. So you can group them within different portfolios, and you'll be able to monitor across each portfolio as per your requirement.
Next question is from Brett. For HVLV CMEN system, there is a benefit in achieving electrical isolation hardwired by Cat6 cable. Any progress in optical fiber patch cable linking?
Not at the moment. It's Cat6 cable that we it's the generic comms cable that gets used out in the industry. So regarding optical fiber patch cabling, we haven't tested this, and I would still recommend using Cat6 in between different devices. So especially when a droplet connection is involved. So yeah.
Yeah, wonderful. From Brett, any progress on IEC 61850 interface capability, Rokoff relays and Rokoff relays talk, i.e. 61850?
So the integration database that we follow, it follows the IEC 61850 standards. So I'm not sure about the relays, but the devices that we're integrated with, including the Gen 24 Fronius, they all follow 61850 standards.
Yeah, wonderful. Question from Edward: is there a differentiation between extenders and access points in the same network?
Good question. So the access point, well, I guess the main difference would be if a user runs discovery from the installer app, and if they're not able to see the inverter, then that would mean that it's either on a different subnet or if it's connected on a different network. A good check for that is to confirm what lease or IP address is assigned to the inverter, and match that or confirm the droplet side as well. That would be the main check. As I said, the devices, inverters and power meters, they will automatically come up in discovery. So if they are on the same network, you should automatically see them, provided Modbus is configured. If they're not showing up, then that would mean that they're on a different network, or if they're hardwired, then there's something wrong with the connection.
Wonderful. Next question is from Bodhi. Is there third-party smart meters that can integrate between the Fronius inverters and the Droplet?
That Bodhi from WA, I wonder if it is Bodhi. I might refer that question to Rod. Basically, we are integrated with other meters, but with Gen 24, they come with their own meters, and we can actually, instead of having to do a separate connection to the meter, we can actually do it through the Gen 24 itself. So it's a lot more straightforward, but I might defer that to Rod.
Yeah, I mean, from our side, yeah, we only have the Fronius meters that are implemented with the Gen 24. So depending on what you're kind of doing, I guess, if SwitchDin can read out other meters and use the data from those other meters, then they can use that for like export control, etc. If it is, however, like a battery system, or you want to, you've got a battery in the system, then you'd have to use one of our meters. Yeah.
So yeah, a bit simple. You just probably want to use the Fronius meter in most instances.
Yeah, so for the smart meter as well as the watt node meter, the Droplet is able to talk to these devices.
Mm-hmm. Wonderful. And a question from Arvin: does the controller have functionalities like demand response, O&M in the near future, predictive, preventive maintenance, or is this already part of the product plan?
Good question.
Yeah, so we already have a demand response controller, the DRM controller. It's I didn't discuss that in today's session. It's available. It's already added in our database, and Fronius inverters. It's also compatible with Fronius inverters as well. So if you want to do demand response controls, we have added all 8 DRM modes, and there is a controller available in the same drop-down menu where a user can select peak shaving controller, multi-site controller, or any other controller. They'll also see a generic DRM controller. And as I said, Fronius is added in that database. So yeah, that's available.
So in the second half of that question around predicting operations and maintenance requirements and the like, again, that's a watch the space question. So our R&D team's working on some pretty amazing stuff at the moment. But as an accredited installer, you'll be receiving all of our updates through newsletters and whatnot. So yeah, please keep your eyes peeled, and there's some pretty exciting developments happening in that space.
A question from Matt: is there a remotely controllable relay contractor port in the inverter, for example, for control of single DRM port?
Yes, I'm not exactly sure on that one there, exactly what you're meaning, but there is by remote controllable. So there's inputs, there's IO inputs, which are DRM inputs, or can be used as DRM inputs on the inverter. So if you have like a DRC or controller, that can be used for that, if that's what you mean. So the device which is talking to our inverter is remotely controlled, but yeah, locally there's ports on there which you can use for DRM type modes. Yep.
Yeah. I think Matt's added a bit of clarification is for control of external devices like an aircon.
Yeah. So yeah. So is that through the inverter or through the droplet?
Yeah, I think you meant the inverter. I mean, from the inverter, it's not. I mean, it's not remotely. I mean, if you've got the droplet, you can remotely configure it as what you need, because you can get to the WebUI remotely on a Snap inverter, etc., or both of them. And it's what we call load management function. So depending on what the power is of the inverter or how much export is, etc., you can use that to then trigger, turning on an external device like an aircon or something else. I'm not sure. I think that's what you meant.
Sounds right.
Any further questions?
No.
No?
Thanks for everyone who stayed on an extra 14 minutes. And yeah, just again, want to say thank you very much for taking the time to out of your busy schedule to check this out. And yeah, I suppose everyone's going to be accredited. You can keep up to date with all the exciting advancements in our technology. And thanks especially to Fronius for helping in partnership for supporting this webinar. And yeah.
Wonderful. And thank you everyone tonight. And a recording will be available, and this will be sent out. A link will be sent to you by email as well. Thank you and have a good night.
Thanks, guys.
Thanks, everyone.
Thank you.
Thank you. Bye-bye.